Hey, this video is a quick reminder of how you would set out to find the length of a segment on a Cartesian coordinate plane. So if I was to look at a length of a horizontal line, right, or a vertical line from here to here, not very problematic because I can say, hey, especially if the coordinates are nice, right? In this case, like I'm going from this spot to this spot. I can just count 1, 2, 3, 4, right? 4. I can count. This is from here to here is 1, 2, 3 units long. So those are pretty straightforward. If the numbers aren't nice, let's say that this starts like maybe here, and I tell you this was 6.21, and then over here I can say this is 12.5. And you're wondering, like, dude, how long is that one? That seems difficult, right? So what's the length of that segment? In general, all I'm going to do is I'm just going to take the 12.5. Where's my calculator? Here's my calculator. I'll just take 12.5. Did it turn on? Yeah. I don't know if you can see that or not, though. Huh. Looks too dark. Let me brighten it. Can I brighten the screen? So I can take 12.5, and from that, I can subtract 6.21. So if I know these x coordinates, right, I've got an x coordinate of 6.21 and an x coordinate of 12.5. I just get the difference in those, and that difference is this is 6.29. So that's pretty straightforward, right? It's just the difference in the two x coordinates is going to give me the length. The big question comes into like, well, what about these ones that are like not horizontal, not vertical? Like, what if you have some diagonal? So I'm just going to sketch this line segment right here. And the question I'm going to ask is, well, how long is that line segment, right? Well, what I typically do is I resolve this to both a horizontal and vertical component, or I can think about a slope triangle too. In fact, for here, I'm going to just go down until I get to this level, and then I'm just going to go over. And when I make this slope triangle, right, one of the things about them is it's a right triangle, right? So I've got this rise, it's a negative number, and I've got the run, and this is a right triangle. So the slope of this is down 1, 2, 3, 4, 5, 6. So it's negative 6, and the run is 1, 2, 3, 4, 5, 6, 7. So the slope, right, is equal to negative 6 over 7. So down 6 units over 7 units. But I'm interested in the length of this, right? So if I'm trying to find the length of this, what I do is I just say, look, the length of this leg is 7. This was down 6 from here to here, but the length of that leg is 6. So what I have here is an opportunity to find C, the hypotenuse of this right triangle. And I'm just plugging things into the Pythagorean theorem, right? I'll take this one leg, 6, and I'll square that. And I'll add to it this other leg, 7 squared. And once I do that, I get that that's C squared. Well, if I want to know what C is, I'm just taking the square root of each side. So I get that the square root of 6 squared plus 7 squared is the length of that line segment. And on my calculator, I can just go, hey, 6 squared plus 7 squared, it is the square root of 85. And that's a fine answer most of the time, right? If you want to look at that as in simplified radical form, I could say root 85, and it gives me, it doesn't simplify, so it's root 85. If I need it as a decimal value, right, this one particular button on my calculator, right, will take that number and convert it into a decimal. So I can say root 85 is the same thing as approximately 9.22. So I can say that's about 9.22. So that's how we could find the length of a segment on the Cartesian coordinate plane if it's a diagonal, right? We're just using the Pythagorean theorem.